Let's examine the various ways we can get data from Excel files. Since Excel is a very popular source of data, there are a variety of ways of accessing that data depending on what file we're in, where the data is, and how that data has been stored. We're going to look at 7 different ways to get data. First, we'll look at getting data from what I call a plain table, and then what is tied very closely to that, getting data from a proper data table. We'll also see how to pull data from named ranges and print areas. Once we understand data tables, named ranges, and print areas, then we'll see how to do file discovery. In other words, instead of starting from one of these objects, scan the file for any of these objects. That will then lead us to pulling data from multiple sheets all contained within a single file, and then how to pull data from multiple sheets that is spread across multiple files by pulling data from a folder. Since this will likely be a longer video, if you're only interested in certain aspects of getting data from Excel files, consult the time codes in the video description so you can go right to that demonstration. And don't forget to download the data files from the link in the video description so you can follow along with me and have access to the solution files and all of the documentation. Let's start with pulling data from a plain table. A plain table or a tabular structure is just a structure where the columns are categories and the rows are records. A plain table refers to a tabular structure in Excel that has not been upgraded to a proper data table, but instead is just simple typed in information. Here we have a plain table of transactional information, and it has a header row. If we click in the data and go up to the Data tab, in the Get and Transform section, we're going to choose From Table or Range. Assuming you're following proper tabular structure rules, Excel will attempt to discover the range of the data and detect whether the first row is a header row. In this case, it selected my data properly, and my first row is a header row, so I'm going to click OK. This brings the data into Power Query, and I'm ready for further processing. One of the quirks of pulling data from a plain table is that Power Query prefers to pull data from a proper data table, not a plain table. If we examine the source step, we see in the M code that we pulled data from the current workbook, extracting the content from a table named Table 1. Now, where did that name Table 1 come from? If we look behind Power Query back to Excel, we can see that our plain table was upgraded to a proper data table. Now that this is a proper data table, on the Table Design ribbon, in the upper left, the table's name is Table 1. Well, what if I didn't want that table to be upgraded to a proper data table? We'll see in a moment how to keep this unwanted upgrade from happening. But for now, we're finished with pulling data from a plain table. Let's now see how to pull data from a proper data table. If I click in the data and go up to Format as Table, and then I'll choose some color scheme. As before, Excel will attempt to detect the data range and determine whether the first row is a header row. I'll click OK. This table is now a proper data table. And I know that because I have a Table Design ribbon with all of the table design features. Proper data tables get names. And in the upper left corner of the Table Design ribbon, we can see that this table's name is Table 3. You can rename this, and I would suggest that you do. So if I were to call this BCTI Sales, that will be meaningful to me once I bring this into Power Query. To bring the proper data table into Power Query, we'll go up to Data and choose From Table Range. As with the plain table, this brings it into Power Query, but if we click on the source step, we can see that we're pulling from the current workbook the content from a table named BCTI Sales. Power Query can also extract data from a named range. If you work with named ranges, you'll do something like this. You'll click in the data, maybe Control A to select the data range, and then go up to the name box and give that range a name. I've given my range the name My Data. So that way later, if I go to the name box dropdown, I can just select My Data and I have the information. To pull this into Power Query, we go up to Data and then From Table or Range. So think about the name of this button. We can pull from plain tables, proper data tables, or named ranges. Once this is in Power Query, if we go back to the source step, we can see the M code is going to the current workbook and pulling the content from a named range called My Data. That's similar to pulling data from a table called Table 3 or BCTI Sales. But if we peek behind the scenes, notice that the plain table we started with that we gave a named range did not get upgraded into a proper data table. Often you'll pull data from an Excel file that is very messy and has no business being upgraded to a proper data table. Well, this is the way you can prevent that unwanted upgrade from occurring. Give the data range a name, then bring it into Power Query, and the data will be left alone. So from this point forward, we do something like promote the header row, set the data types, and then perform further processing. Power Query can also take advantage of Excel print areas. So I have this data in this green box. This is what I want to bring into Power Query, but I don't want any of the data that surrounds it. Well, if you highlight that data, go up to Page Layout, Print Area, and set the print area, notice in the name box, this now has the name Print Area, like a named range. So at any time, if I'm outside of that, I can go to the drop-down and select Print Area and have that data. Well, with Print Area selected, we go up to Data, click From Table or Range. Once in Power Query, I'll go back to the source step, and we can see that we're pulling data from the current workbook, pulling the content from a place named Product Sales, which is the sheet's name, Print Area. We promote the headers, we set the data types, we continue processing. Let's now examine an even more sophisticated way of pulling data into Power Query, and that's through file scanning. In this file, I have a little bit of everything we've already done. I have a plain table, I have a proper data table, and if we look in Table Design, this table is named My Data Table. I have a named range, because if I go to the drop-down, I can choose My Data, and there's the named range. And I also have a print area. If I go to the name box drop-down, print area. So we have a little bit of everything to pull from. Well, suppose I want to pull all of these things in at the same time, but I don't want to create 4 queries to do it. We'll go up to Data, Get Data from Other Sources, and we'll choose Blank Query. A blank query is where you get to build whatever you want. In this case, I want to scan the current Excel workbook for anything that Power Query understands. Power Query natively understands proper data tables, named ranges, and print areas. And currently in development and hope to be released soon, it will also understand dynamic array spilled arrays. But at this point in time, that feature is yet to be released. To scan for any of these supported objects, in the formula bar, we'll type in equals EX, and we're looking for the function called excel.currentWorkbook. I'll hit Tab, and then just give it an open and close parentheses. When we click Check, this will scan the current Excel workbook for any supported content. And as we can see, we have the proper data table named My Data Table. We have the named range named My Data, and we have the print area named Print Area. The nice thing about this workbook scanning is that if you had several print areas and you only wanted to pull data from the print areas, you can leverage this name column for some filtering. So you could go to the filter dropdown and perform a text filter, something like ends with print area. Or if you wanted everything except the print areas, you could say something like does not contain print area or does not end with. I'll choose something like does not contain, exclamation, print underscore area. And then with what's left over, I could go to the content column, expand those tables, select only the desired columns, click OK, and append that data. It's now time to see a very sophisticated way to pull data from an Excel file. Look what I have here. I have a sheet that contains a proper data table. If I go up to Table Design, I can see the name of this table is Addresses. I also have a sheet named Print Data that has been defined as a print area. Also in the file is a separate sheet for each state's sales information. Each of these states' data is a plain table. Also notice that on each of these state-based sales tables, the state name is not recorded at the transaction level. The creator of this file assumed that if the user wanted to know what state the transaction came from, they would just look at the Sheet tab. Well, if we bring these tables into Power Query as is, we'll lose track of which sales came from which states. So we're going to have to create some sort of tracking information to replicate the sheet name into a new column for each table. But I want to avoid this proper data table and I want to avoid this print area. Unbeknownst to the viewer, there are also some hidden sheets in this file. If I right-click a sheet and go to Unhide, I can see there's a sheet in here called Secrets. And if I unhide that file, here's the secret data. I don't want that in my query either. I'm going to rehide that sheet. Now remember I said that the Excel Current Workbook function can natively detect data tables, named ranges, and print areas. But these are plain tables, and they're not to be upgraded to proper tables. I can't name them, and I'm not going to set them up as print areas. So how do I discover these? We do that through the Excel workbook connector. Let's close this file. I've started a blank workbook, and I'm going to go up to Data, Get Data from File from Excel Workbook. I'll browse to the location of that Excel file, click on it, and choose Import. The Excel Workbook connector does not assume you want the data from every sheet in the file, so they give you a chance to pick and choose exactly which sheets you want to pull from. Now, if you're not sure which sheet you need, you can click on a sheet name on the left and preview that information. Notice the icons. It's telling you these are sheets. You can see the little tabs. But the addresses, this was a proper data table, so it gets a different icon. We also had that print area. The one thing you don't see here is that hidden sheets, secrets, but we'll see that in just a moment. Now you can pick just one particular sheet, or you can go up here and click the Select Multiple Items option, and that gives you the option to check the boxes and pick and choose exactly which sheets you want. Now, I would discourage you from doing it this way, because this will hard code into the M code those specific sheet names. And if you get different sheets the next day that have different state names, that code's going to fail. I want every sheet, not print areas, not tables, not hidden sheets. But I'm going to temporarily bring everything in and then do some filtering. To bring all of the content in, we don't pick any particular sheet or object. We click the file itself. Now here's something that's a little bugaboo of mine. I'm not a fan of this icon. This is a folder icon, but we're not pulling from a folder. We're pulling from a file. And I really wish this was the Excel logo. But I guess they're trying to denote that this is some sort of containing object, so they use the folder icon. So I'll uncheck Select Multiple Items, check the file itself, and then go to Transform Data. Unlike the Excel.CurrentWorkbook function, which can detect data tables, named ranges, and print areas, the Excel.Workbook function will scan the file for metadata. You can do some great things with metadata. First off, we see the names of all of the sheets here, and we also have a column called Kind, and we can differentiate between a sheet, a table, and a defined name like a named range or a print area. And you could use this column for, say, filtering out anything that's a table or a defined name. An interesting aspect of the Kind column is that sometimes the same data will appear twice. What I mean by that is, notice this row 3 entry named Proper Table. This is being classified as a sheet because it's looking at the entire sheet called Proper Table. But on that sheet is a actual proper table called addresses, and it is being classified as a table. So this table object is actually contained on this sheet object. If I peek into the table that is the entire sheet object, we can see in the preview that this has very generic headings because this is looking at the entire sheet. But if we peek into the table of the table object, notice that it has proper headings. So if I were trying to get this content, I would pick the table version of the data as opposed to the sheet version of the data, because then it will just come in with promoted headers. So if you want everything on the sheet, choose the sheet. If you want just that one table on the sheet, choose the table. Now in this scenario, I don't want that sheet or anything that's on it. So when we filter, we have to make sure we filter out not only table objects, but also the sheets that those table objects occupy. You'll basically have to do a double filter. We also have a column called Hidden, and here's where we can see that Secrets sheet that was hidden in the Excel workbook. So if you didn't want any of the hidden files, you could filter out the trues. So let's do just that. We'll go to the filter for Hidden and filter out all the hidden sheets. Next, we want to make sure we're only returning sheet-based objects, not proper tables, not named ranges. So we'll go to the filter for Kind and make sure that we're only selecting sheet-based objects. Now remember that the proper table and the print area were referenced twice because it's an object on a sheet and both things are recognized. So we could take either the name column or the item column and filter for keywords. Now in this case, I'll go in and perform a text filter and say that I only want to keep things that do not contain either the word print and do not contain anything with the word table. Now obviously your words may be different than mine and you'll have to adjust your filters accordingly. Now we've isolated the tables of interest. Remember that inside each of these tables, the transactional information does not have the state defined at a record level. So when we expand these tables, we need to make sure that the state name becomes basically a transactional history stamp. We'll select the name column, hold down Control, select Data, and then right-click one of those selected columns and remove the other columns. Next, we'll go to the data column, click the Expand Table button. We want every column in these tables. We don't want column prefixing, and click OK. So we can see that we have the data, but we need to get rid of the redundant headers and use the first row as a header row. Before we do that, notice the first column's header name is name, and the first row that contains the header, this first row is using a state's name as its header. So when we use the first row as a header, whatever first state it happened to grab becomes that column heading. We need to rename that to state. Now what we do not want to do is double-click this heading, rename it to state, because if you look at the M code, it hard codes Arizona. But what if tomorrow's file, Arizona, is not the first state in the file? What if it's Texas? Well, then this step in the query is going to fail. So let's get rid of that rename column step. We're also not in a position to do data typing yet, so I'm going to delete that step. So now we've just promoted the first row to a header row. To rename the first column to state and not have the state name be hard-coded, we're going to use a little M-code trickery. I have an entire video on this process that you can click on in the upper right corner if that appears, but if it doesn't, you can click the link in the video description for a more detailed explanation of this process. We'll start off with naming it statically. So I'll double-click on the first column header, rename it to state, but then in this table.rename column statement, I need to make this static declaration of Arizona dynamic, so it's based on the column position, not based on the content in the column. We will do that by retrieving the column names from the previous step, and if we look at the previous step called promoted headers, the previous step's first column name is Arizona. So we'll retrieve that previous step column names, and then say whatever's in the first column, rename it to state, no matter what it is. So let's begin by deleting the static information, and then we'll type in table.column names. We're trying to pull the column names from the previous step called promoted headers. So you can either copy that and paste it, or you can just type in a # and get a list of those steps and just arrow down to promoted headers. Now outside of the parentheses, we need to point it to the first column of that promoted headers step. So we have to place inside of a set of curly braces a column position. Now remember, Power Query starts counting at 0. So the first column is actually the 0th column. We'll click check, and we don't really see anything change. But notice the previous step, that column's name was Arizona. In the following step, it's now state. But this is now a dynamic reference instead of a static declaration. Now that we have proper headings, I'm going to click one of those column headings, press Ctrl-A on the keyboard to select the entire table, and then go up to Transform and initiate a data type detection. Now the first column received a text data type, which is good. The date column, however, received an any data type, and the reason for this is there's a mixture of dates and text, and so Power Query got a bit confused. Now the good news is we're going to leverage this confusion to remove the redundant headers. By forcing the date column to a date data type, anything that was not a date is turned into an error. Well, if there's an error in that column, that's a redundant header row, and it's a row I don't want. So now I can right-click on that date column and remove the errors. And now I have removed all of the redundant headers. Now I'm going to go back to that change type step and refine the other columns. So sale number, maybe I'll make that a text-based column to account for leading zeros if I have them. Item number will be text as well. Quantity will be a whole number. Scroll over, item amount and sale amount. I'll do a right-click and change those to currency. Checking the next step, everything's still working. Anything past this point is just standard Power Query processing, sorting, filtering, grouping, etc. Our final method will be to pull data from multiple sheets spread across multiple files. This folder named Regional Sales contains 9 Excel spreadsheets, each containing sales data from the states of that particular region. So if we were to open the Mountain file, we see these sheets across the bottom. Each file has a variety of different sheets for the states in that region. We want to pull all of the 50 sheets spread across the 9 files and combine it into a single table. To do this, we will use the From Folder connector. In a blank workbook of Excel, we'll go to Data, Get Data, From File, From Folder. Browse to the location of the Regional Sales folder, click Open. This will give us a preview of the metadata of that folder. If you want to bring in each file's contents as a separate combined table, you can choose the Combine option. If you just want to dump this metadata back into Excel, you can choose Load. Well, we want to go into each file, extract every sheet, combine it into a single table. So we're going to go to Transform Data. Notice in the formula bar, we're using a function called folder.files. By the way, folder.files scans the current folder and all subfolders. If you don't want to scan subfolders, you can change this to a function called folder.contents. I don't have subfolders, but if I did, any files in the subfolders would have been filtered out. So we'll put that back to folder.files. You can do many creative things with the metadata in this query because you can filter for things by, say, folder path, or by the date created, or when it was accessed, or what file type it is. The content column contains the actual Excel data, and of course I'm going to keep that. But in the sheets of those files, there was no record of the region because it was assumed the user would just look at the Excel file name for that. But I want to preserve these region names as a tracking column within the internal data. Well, the first thing I have to do is get rid of the -sales.xls on each of these. So I'll select the name column, I'll go to Transform, and then Extract. And I'm going to extract all the text before a delimiter. And in this case, my delimiter is going to be a space dash. So I'll type in a space, a dash, hit OK, and now I just have the region names. Before I do the extraction of the binary files in the content column, I want to get rid of the remaining metadata columns. So I'll select Name, hold down Control, select Content, and then do a right-click Remove Other Columns. Notice that the columns switch their positions. That's a fun little bonus trick based on the order you selected the columns. So I could do a column removal and a reorder in one step. Now it's time to extract the content from these binary files. Beginners are always taught to click this button here called the Combine Files button. I call it the Sad Robot button. But that's going to create an entire series of helper queries. And a lot of people don't want those helper queries. If you want to know more about the helper queries and how to avoid them, click the link in the upper right if it exists, or just find the link in the video description. That video may be my most viewed video. What I'm going to do is go up to Add Column, Custom Column, and I'm going to use a function called Excel Workbook. Open parentheses. The workbook argument is looking for binary files. Well, those binary files are located in the content column. Close parentheses. Hit OK, and I now have another column of nested tables. And if I look in one of those tables, I see the same information I saw earlier when we were using the From Excel Workbook connector and we retrieved the metadata of a single Excel file. I no longer need the content column. I'll remove that. Looking in the tables, the data in those tables do not contain their state names at a transaction level because it's assumed the user will just look at the sheet name for that information. To retain that information, I'm going to keep the name and data columns. So I'll go to Expand Table, select Name and Data. I'm not going to do column prefixing. Click OK, and I now see the region, the state name, and the nested table of sales. I'm now in a position to extract the actual transactional data from these nested tables in the data column. So we'll do another Expand Tables. I want every column. I'll click OK. We now have the region, the state, and then the rest of the sales information. From this point forward, it's a matter of header promotions, data typing, and then getting rid of the redundant headers. Let's go up to Home and use the first row as the header row. Now this is great, but notice the first and second columns took on the names of their first encountered region and state. And if we expand the formula bar, we can see that hard-coded here and here. Now first off, we were not ready for data typing yet, so we'll go ahead and delete the change type step. But the problem still persists. So what we'll do is the trick we used before, which is to dynamically rename those columns. So for the region, I will temporarily manually rename that first column to region. This gives me everything I need except for the fact that right here, the prior name of the column is hard-coded. We want that to be discovered. So we'll replace this information with a table.columnNames function, open parentheses. We'll point to the previous step, promoted headers, close parentheses, and then in curly braces, we'll point to the 0th column of the prior step. Give it a check. This first column is now called region, and it's done dynamically. We'll do the same thing for the second column. We'll start off with a hard-coded state, but then we'll take the hard-coded Illinois and replace that with a table.columnNames function, open parentheses, and point to the previous step's name. And we can either point to the previous step's name or the promoted header step just for consistency. It won't make any difference. so I'll keep it consistent and use the promoted headers step. Close parentheses, and then curly brace 1, because when counting in Power Query, 1 is the second column name. Looking through the steps, here's where we initially expanded the data. We promoted the first row to a header row. It took on the names of whatever was in the prior step. We then renamed the first column to region dynamically and renamed the second column to state dynamically. Now it would be time to do something like select a column, Control A, go to Transform, Detect Data Type, but then we have to figure out how to get rid of all of the redundant headers. Well, as before, we can take the date column, which is currently in any data type, and set it to a date data type that will render all of the redundant headers as errors. We can now right-click the date column and remove the errors. Now, if this were me, I would probably do something like sort the table by state in ascending order, and then maybe do a secondary sort by date as an ascending order. And because there are likely to be multiple sales on the same date in the same state, maybe I'll go over to sale amount and do a descending sort. I also noticed I probably could have done some better data typing up here, so I could go back to the change type step, set quantity to whole number, and then select item amount and sale amount, and do something like a right-click change type currency. Going back to the last row in the query, here's all my data. Now, as with all of these examples, the final step after you've done your further processing is to probably close and load this out as a proper table back into Excel. Here's my table, and if I go to my state dropdown, I can see all 50 states' content are here. So as always, let me know what you think about this. Are any of these techniques new to you? Can you think of better ways to do these steps? Put them down in the comments. I always like to see how creative people can be. Remember to download these files from the link in the video description so you could go back and do this yourself, or check out the built-in documentation in all of the M code of the solution files. Thank you for watching, and remember, at BCTI, the learning never stops.